If x plus 1 over x is equal to 1, then what's x to the power 2024 plus 1 over x to the power 2024? Basically, two different ways. First, if I multiply this equation by x on both sides, x squared plus 1 is equal to x. Okay, so I can immediately find out x squared is equal to x minus 1. Right? Now if I say, okay, x multiplied by x on both sides, so x cubed plus x equals x squared this time. Now, knowing I've already found x squared is equal to x minus 1, okay, so immediately I have moved this x onto the other side. So x cubed immediately equals negative 1. Right? So there's no coincidence, because the question is pre-designed in this way, so that it is actually a nice integer. So in that case, I can immediately find out what's the ratio of 2024 divided by 3. Right? What's the remainder? What's the quotient? So times 6, 18. 22, so times 7, 21. So I'm left with 14, so times 4, 12. Remainder is just 2. Okay, so immediately I have, so x to the power 2024 is equal to x to the power of 3 times the quotient 674, and plus the remainder. Now, that is equal to immediately x to the power 3 to the power of 674 plus 2. We just multiply by x squared according to power rule. So immediately I have x cubed negative 1, negative 1 to the power of 674 times x squared. So that's immediately x squared. Right? But what's that? So similarly, I have 1 over x to the power 2024 immediately. That is equal to 1 over x squared. Right? For the same reason. Only difference is that I have reciprocal. So now I just need to work out x squared plus 1 over x squared. Right, so this is that. So that question becomes this. Right? So by the way, I can just have x plus 1 over x, knowing that equal to 1. Okay, if I square both sides, also equal to 1. So x squared plus 2 times x times 1 over x plus 1 over x squared equal to 1. Okay, this is just 2. Right? So x squared plus 1 over x squared immediately equals, so move this 2 to the other side, negative 1. So here's the second method. Like I said, there's no coincidence. Right? So that designed in such a way it is actually simplifiable. Because if I just rewrite this multiplied by x on both sides, have x squared plus 1, like I said, equal x squared minus x plus 1 equal to 0. And we immediately solve for x equal to half of negative b 1 minus square root of b squared minus 4ac. Immediately negative 3. So x is equal to half of 1 plus minus square root of 3 times I, imaginary unit. So we have two complex solutions. And from the graph, it's easy for us to see that, right, since x is a complex plane, so the x coordinate is just half. Right, here's half. The y coordinate is plus or minus square root of 3 over 2. Let's go here, or down here. Right, so here. 2 solutions, complex plane. So immediately I have the modulus or the length of this complex number is just square root of half square plus square root of 2 over 3, 3 over 2 square to 1/4 over 3 over 4. So the length is just 1, right? And so the angle would be just, right, here's sine, right? Sine this angle is just square root of 3 over 2. Cosine this angle is half. So immediately this angle should be exactly 60 degrees. So pi over 3 or negative pi over 3. Right, 2 solutions. So immediately we can represent it in terms of cosine the angle. So plus or minus pi over 3 plus I sine plus or minus pi over 3. There's no coincidence. So it's actually nice and simplifiable. So that way, immediately, according to the rule of the complex number arithmetic, the power rule, if I want to raise x to the power of 2024, for example, all I have to do is to, first of all, raise to the original modulus to the power of, to this power. But the original modulus length is just 1, so it doesn't matter. Then I can just apply the angle by the power, right, according to De Moivre rule. So cosine plus or minus 2024 over 3 times pi plus I times sine of plus or minus 2024 pi over 3. And if I remember correctly, I previously did some division, long division. So the angle, let's call that the angle alpha, if I'm correct, plus or minus, I think it's 674 plus 2. Okay, altogether 2 over 3 together times pi. Right? So immediately we can see that immediately we have a multiple of 2 pi. Right, this is then, so even number times multiple of 2 pi. So it doesn't matter. This can be just ignored. Right, same effect. Right. All we have to focus is on this angle. Right? Doesn't matter cosine, sine, as long as we add a multiple of 2 pi. So the same effect. So all I have to work out is this result, right? Is it simplifiable? 2 pi over 3. And of course, x to the 2002. So for the same reason, 1 over x to the 2024 similarly should be equal to x to negative power and it should be equal to, all I have to do is to add a negative. So cosine this time, right? Previous plus or minus. So minus plus 2 pi over 3. I sine, right, minus plus 2 pi over 3. Okay, so immediately I can have x to the plus 1 over x to the third is immediately equal to, so cosine positive 2 pi over 3 plus I sine 2 pi over 3. And so this is plus minus, that is minus plus. So if this is plus, so at the same time this should be plus minus. So cosine minus, so cosine is an even function, so it doesn't matter, still plus. Right. Sine is odd function, so immediately the minus sign pulled out. Sine 2 pi over 3. Right, the first solution, so immediately twice cosine 2 pi over 3. Right. Cosine 2 pi over 3, simple. Right, here is third pi, so 2 pi over 3, twice of this angle, so here, right, and cosine, so here, cosine this angle, half, cosine this angle, negative half, so 2 times negative half, okay? Or like I said, if this minus, then this plus. So cosine minus, right? But cosine minus still cosine positive, right? Sine minus is minus pulled out. I sine 2 pi over 3, right? And then so this minus and this plus, so cosine plus. Okay? Sine also plus. So minus plus, like twice of cosine, still the same thing.